Assalamualaikum and very good afternoon. See you again, class. So today we will teach you about the discover attribute and operation via sequence diagram. Yeah, this is very important step. After you discover your object and class, and then you create and represent your the relationship. Yeah, for object class on sequence diagram on the and also the class diagram. So you need to discover the attribute and operation. Okay. So this under cover under lab 8. Yeah, lab 8 is equivalent to lecture 8, operation and attributes. So what we cover in this lab is we define and represent attribute for object class on sequence diagram, define and represent operation for object class on sequence diagram, and lastly we define and represent attribute and operation on the class diagram. So the step number one and number two is we show a process. A process how you discover the attribute and operation. Uh, if you familiar with the object oriented software development life cycle, so I think you don't need to follow this process. So this is for the beginner, and not only for the beginner. If you uh, forgot how to find, or you feel difficulty how to find the operation and attribute while modeling your application, so you need to go back to your sequence diagram, and you need to refine, and you need to uh, again and again understand the process, and you update your sequence of flow of your use case. Okay, so I will show you the continuation from the lab 7, where we already create the class diagram, yeah, without operation and attributes from the sequence diagram. Okay, so we in lab 7 we discover the relationship through message that we define in the sequence diagram. So from the sequence diagram we create the relationship, yeah, we define and we represent the relationship between object class discovered. Yeah. Okay, I need to delete this one. Okay. Okay, how the question is how we want to uh, find the attribute and operation, or in Java they call it method. Yeah. First step is after you define and represent your relationship in the sequence diagram. So this is a relationship, yeah, through the message. Yeah. So in sequence diagram they call it message. So this is a flow of event of your use case. Yeah. So what you need to do is you look at the arrow that go to these objects. So when the arrow which a message enter input. So enter input is the operation of the emit screen. Look at the arrow where it go. So if the arrow go to the emit screen, and this is a emit screen for the operation of the emit screen. Yeah? Enter input is the operation for emit screen. So if the arrow go to the system, so this submit input is a operation owned by the system. So the submit verification carry the parameter ID and input, and it goes to the patient DB. So this object. So this operation is owned by the patient DB. And look at this step number 4, flow event number 4, verify patient is go back to their own, yeah, their own object that called self message. Verify patient. So this verify patient operation is the patient DB operation. Okay. Add patient is the operation of patient DB. So when you model your dynamic behavior of your use case, so label it. Yeah, label means give a name of the process. Let's say enter input, submit verification, verify patient, add patient, and send a message. Okay, I change this one, send message. So become a verb. Yeah, send message. So when you look at the send message, where the message goes, it goes to the admit screen. Yeah, so the send message is owned by the admit screen. So now we got the idea. Okay, we already got the idea. So we have a 6 operation which located in different object. Okay, now we start with the admit screen. Yeah, admit screen. Uh, we start to create the operation for admit screen. So look at this left line of the objects. So there are 2 operation. Where you go to your class diagram, admit screen, double click on the operation. So so the start UML provide a very easy to create the operation and attribute. So now you create the operation, right? So this one enter input. Sorry, enter input. Okay. Then another one is send message. Okay. So we already create 2 operation. So you look at your sequence diagram, enter input, send message. So what is the attribute bring by this operation, this message, enter input? PID and name. This attribute is owned by the emit screen, and also the send message. They bring the attribute message. So you go back to your class diagram, then you start to create the attribute. So PID. Okay, you can define PID is what string. Okay, and then another one is a name, right? Name. Okay, maybe name you can define as a varchar. Varchar. And then another one is a message, right? Message. You use a short form MSG, string. Okay. Or you can leave it the data type here. You just put the name of attribute only. So at the beginning, don't make yourself difficult. So just list the attribute discover from the sequence diagram. Later you can define the data type. Okay, and then so go back to your sequence diagram. So look at the system object class. So this is a controller. So easy to remember. So put the stereotypes. So controller. Control. CONTROL. Okay, control. So control got 2 operation. Yeah. Oh no, sorry, 1 operation. Submit input. What they carry the value is PID. So go to the class diagram. The operation name is submit. input. Okay, and the attribute is PID. Okay. Then look at your database, yeah, patient DB. What are the operation discovered in these objects? So go back to your sequence diagram. Okay, so we have submit verification, verify patient, add patient. Three operation: submit for verification. Go to your class diagram. Same process. Create the operation. Submit verification. Okay. Add verify patient. Okay. Add patient. Okay. Only three operation we discover from this from here. So submit verification bring PID and input. Input in the object type, yeah, means that there are a lot of data that encapsulate in the input. So they call it object. They use an object. So PID and object. So we update the class diagram of patient DB class. We add, we create the attribute name PID and input, right? Input is a object or in string lah. String, yeah. It's a long string. Okay. Okay, class. What else that we need to update the class diagram? Okay, the patient input. Verify patient. Okay, verify patient. So normally they bring the input also, add input and so on. Okay, this is basic. So you need to uh, update your sequence diagram based on the flow of event of your use case. Yeah, so you need to update your use case specification as well. Otherwise, your system becomes simple. Yeah, so I think this is a place where you need to put the message. You need to think about the system and the requirement, and of course you need to update this. So I can show you, but it will take 2 hours or 4 hours to complete one sequence diagram for complete use case specification. When we don't have time, we give you a simple example, then you can continue your object model through sequence diagram. So sequence diagram is a object behavior. It's a dynamic process uh, of modeling your object and class. So this is all object. So you can upgrade this one by putting the stereotype so that you easy to understand. Okay, this is a boundary or something. So this is a boundary. Yeah. Okay. So this is a entity. So the beauty of using the star UML is very easy to manage your diagram. This is entity. Okay. Okay, class. We complete to discover the operation and attributes. Yeah. we show you the process how to discover, how to define and represent the operation and attribute on your class diagram and also in on your sequence diagram. So this is an input. So this is an input for you to discover the attribute and operation, especially the operation. The input, I think the attribute input is very subjective and very difficult to define in limited space here. Uh, you can define your attribute uh, via the ERD, entity relationship diagram. Yeah, you can use ERD, yeah, like this, uh, to model your the data requirements. Okay, the data requirements. Okay, I think that's it. I give you a basic step how to discover the operation and attribute. Next step that we need to design, design the operation signature. Okay, so we will cover later uh, how to discover your operation signature. Okay, operation signature, for example, send message. So in star UML they already have a template. So when you click on the send message, they have a stereotype, name, parameter, and so on. Yeah. Okay, for example, this one is let's say send message is a message. So message is uh, so message is a sorry in message it's a string. So the data type is a string. Okay, and the return value is a notes, a remark. Okay, so this is signature. Okay, so you instantiate the method, you bring the variable, and this is a return value. When you fire the send message method, so you bring the message value, and then you expect the return is a remarks under remarks. So this is a operation signature. Okay, operation signature. So you need to update your attribute. For example, this is a bacha, for example. Okay. I don't know whether we can put the string length here or not. Cannot accept. Oh, cannot accept. So just give the type only. Okay, bacha string. So this one message. Uh, the data type is a string. Yeah. So PID. So you need to update it because this become your structure of your system. Yeah? Structure of your class should compete with the data type and return value. PID is a string. Okay. So this attribute and operation, so you need to design it. design according to the system requirement. Okay, so you can add more, add more the attribute later after you uh, do analysis again and again. Okay, class. I think that's all. The lab 8, how to discover the operation and attributes. Yeah. And don't forget that after you model your class diagram, and then you need to copy this class diagram and paste into your main document here. Yeah. Update. Okay. Thank you very much. And Assalamualaikum.